Today let's learn about the stack data structure. If you make the right use of the data structure, it will help you to solve the problem more efficiently in terms of time and memory used. If misused, it can make your program worse too. We can define stack as the linear data structure which uses the last in first out (LIFO) operation technique, where the operation can only take from one side of the data. Now, let's try to understand the stack using the analogy of a container. The container has one open end, from which things can be put inside. You can take out things inside the container from the same end only. So, let's put in first data inside the container. Put the second data inside the container. It will be on top of the first data. Similarly, you can put the third data on top of the second data inside the container. The process goes on. Basically, we demonstrated one operation that we can perform on the stack. It is called push operation. The push operation can continue until the container gets full. It is called the size of the stack. You can observe that the data are placed sequentially, which defines the linear structure of the data. The other operation that you can perform on the container is to take out things from the container. You can only take things from the container one at a time. That too, from the top of the container only. This is called pop operation. You can take out the last data from the container at first. It shows the LIFO operation technique used. This is how the stack data structure works. Let's discuss some of the basic types of operations that we can perform on a stack. The first one is called the push function. As we have seen in the case of container analogy, the push function will insert the data inside the stack. It takes one argument, the element that you want to insert inside the stack. The second one is called the pop function. The pop function will delete the element from the top of the stack. The third one is called the isEmpty function. It will check whether the stack is empty or not. Lastly, the function that we will see is called the isFull function. It will check whether the stack is full or not. Now you know how the stack data structure work. Let's implement the stack data structure using the C programming language, which will have push, pop, isEmpty, and isFull functions. I am using Sublime Text Editor to write code and the bash shell to compile and run the C program on the Ubuntu operating system. Let's include the standard input and output header file called studio.h. Define the stack size variable. I will name it as size of length 4. I have used the define directive to declare the size variable, as the size of the stack does not changes throughout the code. I will use the global variable called stack to store the stack data structure. The last global variable that we will use is called index. It will have default value of -1, which means the stack is empty. The index value will point to the top of the stack. Basically it is the index of the array that we have used to store the stack value. Now let's define the main function of the program. We have defined the main function. Now let's define the push function. We will define the user-defined function in C outside the main function. I will name the function as push, of return type void. Since I don't want to return any value from the function, it will just insert the value in the stack. The function will take one parameter called element. Before we insert the element inside the stack, let's check whether the stack is full or not. If it is full, we will return a message saying the stack is full. If it is not full, we will insert the element inside the stack. Then we'll print the message saying the given element is inserted inside the stack. That's set, we have completed our push function. Let's define the pop function. I will name it as pop, of return type void. Because I don't want to return any data from the function, I will just remove the top element from the stack. Before you remove the data, check whether the stack is empty or not. If it is empty, I will display a message saying that the stack is empty. If it is not empty, then I will display a message saying that the top value is pop out from the stack. Then I will remove the top element. In order to remove, I will just decrement the value of index variable by 1. Because you can overwrite the value in that particular index before the decrement if you want to insert data later on. The program will consider it as junk value at that index. Now you have successfully defined the pop function as well. Let's define the isEmpty function. It is very easy. I will name the function as isEmpty, of return type as void. Check whether the value of index variable is -1 or not. If it is -1, the stack is empty. I will display the message saying that the stack is empty. Else I will display a message saying that the stack is not empty. You can make the isEmpty function as Boolean function. To do that, just change the function return type as int and then return 1 if the stack is empty, else return 0. Now you can call this function in the pop function, to check whether the stack is empty or not. Lastly, define the isFull function. I will name the function as isFull, of return type void. Check whether the stack is full or not. If the index plus 1 equals to the size of the stack variable, then the stack is full. I will display the message saying that the stack is full. Else I will display a message saying that the stack is not full. Like isEmpty function, you can make the isFull function as Boolean function. To do that, just change the function return type as int and then return 1 if the stack is full, else return 0. Now you can call this function in push function, to check whether the stack is full or not. Let's call all the functions from the main function to see whether the program is working correctly or not. I am calling a set of push, pop, isEmpty, and isFull functions to check the working of the code. Now I will compile the program with the following command. The compilation is successful. Let's run the program code with following command. Let's see the output to check the correctness of the program code. First I have called the push function, with the argument value as 1. The output should be, 1 is inserted inside the stack. The output is correct. Next I have called again the push function, with argument value as 2. The output should be, 2 is inserted inside the stack. The output is correct. Next I have called the pop function. The output should be, 2 is pop out from the stack. The output is correct. Next I have called the isEmpty function. The output should be, stack is not empty. The output is correct. Next I have called the pop function. The output should be, 1 is pop out from the stack. The output is correct. Next I have called the isEmpty function. The output should be, the stack is empty. The output is correct. Next I have called the isFull function. The output should be, stack is not full. The output is correct. I have called 4 consecutive push function with value from 1 to 4. You can see that the output is correct. Finally I have called the isFull function. The output should be, the stack is full. You can see I have got the correct output. So we can conclude that I have successfully implemented the stack using array in C programming language. Don't forget to like, comment, and share the video. Also, if you want to learn more, subscribe to my channel and click on the notification bell button to get notified for new videos. Thank you for watching. Keep learning.